All right, we're at the Hyatt Regency on Capitol Hill, Washington, D.C. Dolphy Gilpin is your instructor here, and we're using the PDM 5x12 matrix as our, if we should use the word enhancer. What has happened is that during the PDM methodology, we have generated a lot, exponential amount of 3x3 matrices and 4x4 and 2x2s. And we wonder what we should do with these outputs. We have used them. Every 3x3, 4x4 is a potential circuit with their elements, resistance and capacitance, and resistance, capacitance, and what you call the other one, inductance. Nevertheless, let's continue. We have just done find I1 in our previous session. We're going to be finding I2, and we are referring now to this circuit. We're referring now to this circuit which we have found I1. And very quickly, let me draw the circuit here. Little inductance there. Now this is a resistance. This is a voltage source. This is 100 angle 30 degrees. And this is 100 angle 0. This is 0.02 ohms. This is 1 ohms. And this is J3. And your I2 was going in this direction, counterclockwise, and I1 was going clockwise. That is the circuit we're referring to. And we found I1, now we're going to find I2. And I2 now quickly is equal to 1.02, 1 plus 0.02, which is the element, and then plus J3. It's equivalent of the R11, mesh 1, and R12 here will be equal to 100 angle 0, which is this. This now will be R21, which is 1 plus J3, and at 100 angle 30. And find the determinant of that over del. I've used, let me just put, we were using delta, but now we're using a del for a reason that is to come. The del is used for the divergence and the copier and all of that. And whereas delta is used for small increments. So I've changed over to del, and so del is now 0.127 angle 71.4. And when we do the determinant of that, we find that that's equal now to 162 angle 176.2. And that's over now 0.127 angle 71.4. And that will be equal now to 127.9 at the angle 104.8 degrees. And that will be in amperes. Now the power supplied due to the voltage source V1, this is V1, this is V2. The power supply, power, will be equal now to, as a power due to V1 equals 100 angle 0. Will be equal now to power 1 equals 100 into 130.8 cosine 74.8. And that's equal to 34.315 kilowatts. That is the power due to the voltage source V1. We have found I1 to be 130.8. And And so we multiply P is equal to I squared R or P is equal to VI. So rather, we use P equals to the voltage times the height that we found. And so that's equal now to 34.315 kilowatt. Now P2, power 2, that is due to now I2, would be equal to 127.9. P is equal to VI, but you also have to bring in the angles. And so we get now cosine 104.8 minus 30 degrees. And that's equal now to 33.558. 33.558. And power is in now kilowatts. And so we say now that power 1 plus power 2 is equal to 67.873 kilowatts. And if you want now, we could do the power dissipated now, the summation of P. When we do that, we get 67.93 kilowatts. All right, so here we have found I1, I2, and we have also found the power due to I1 and I2 via the voltage sources. P equals VI, or P equals I squared R, but we could use P equals I squared R for this. But since we found the current, we use P equals VI. We could find that the power dissipated at each element, the power dissipated by this would be I squared R, this I squared R. Power dissipated by this would be this resistance, I squared R as well, and so on. Power at these elements would be the power of this plus the power of that. So we get here 67.93 kilowatts. Let's take a break and then we'll come back to do some more circuit analysis. We'll go on to some 3x3 circuits where we should generate some 3x3 matrices.